And welcome back, everybody. Picking it up again with machine learning and the basics. Basically, there are two types of machine learning. There's supervised learning, which is means that the model gets trained on labeled data. Where the input and the output pairs are known. So, for example, email spam that I'd mentioned, that classification is a type of supervised learning. The model is going to learn from labeled data and it's going to make predictions on whether the email is spam detected or not. Now, unsupervised learning is the other type of machine learning. So here the model is trained on unlabeled data. So we're trying to find hidden patterns or structures. So maybe as an example, a customer is in this, we're segmenting a market, right? So in unsupervised learning, the model is going to find hidden patterns in unlabeled data, like maybe there's various customer segments that it's finding. There are other types of machine learning out there. Reinforcement learning is another one, but I really only intended to address supervised and unsupervised model learning. But basically, since I've touched on it, reinforcement learning, here the model learns by interacting with an environment and it's receiving rewards or penalties in that interaction. So, for example, training an AI to play a video game, right? With reinforcement learning, that model or that agent is going to learn by interacting with the environment around it and receiving feedback. For example, if you're training the AI to play chess in a machine learning approach, that would be reinforcement learning. Machine learning it's important because it's not AI itself as we know it today, but it's an important part of it. It's the backbone of so many of these AI applications, and it's powering everything from recommendation systems to autonomous vehicles, etc. So, touching on that. Now, I did want to mention then turn to discriminative AI. For example, in various economic industries like the credit industry, right? So, discriminative AI is a type of artificial intelligence that's going to focus on distinguishing between the different categories or classes of any given data set, right? So, discriminative models get trained then to learn the boundaries between the classes, essentially answering the question, given a certain input, what class does it belong to, right? And so discriminative AI models are typically, by applying these classification tasks, the goal here is to assign an input to one of several predetermined categories that you're looking for. And so these models are really mapping data to a probability distribution over possible outputs that we've labeled that can distinguish them based on various categories. So just touching on that along the way. And you can see part of that discriminative AI can use this decision tree along the way, just as an example, right? Generative AI is so much of the conversation. And this, as I touched on lightly before, refers to a branch of artificial intelligence that really is focusing on creating new content. And that's really the difference. Where machine learning is going to focus on predictions largely, generative AI is creating new content, new text, new images, new music, even new code for writing programs, because its learning patterns are based on existing data, right? So, unlike a discriminative model, which I just touched on, that's meant to classify or predict based on input data, right? Now, a generative AI model is going to generate entirely new data. It's new data that resembles the data it was trained on. So, again, that break, discriminative machine learning is going to classify or predict, right, categorize something based on the model that it's been trained on. But a generative AI model is now going to create new data that resembles what it knows. So generative AI basically it learns the underlying distribution of the data, and what it's doing is it's generating new instances from that distribution. And these models can be built using various techniques like deep learning, it especially applies neural networks in generative ways, right? And so Chat GPT-3, GPT-4, which is and growing, are using these advanced language models developed by this group called OpenAI. And what it's doing is generating human-like text based on our prompt in a completely unique answer. And now it's capable of writing essays, answering questions, summarizing content, etc. This is very popular with chatbots we've all used, content generation, coding I mentioned in software, GitHub, for example, I think it's GitHub Copilot, language translation, etc., etc. So it's very exciting along the way. Now, I wanted to get to neural networks, just touch on that. So neural networks are the backbone, as I mentioned early in this presentation, part one, of most generative AI models. So in the context of generative AI or Gen AI, neural networks are designed to learn the patterns it needs from very large, massive data sets. And when it's learning from those patterns, it is generating new data that resembles the original point, right? So these networks consist of layers now of interconnected neurons, layers of AI that process and transform input data through a series of mathematical operations, right? And so there's a lot to it, not to touch on it all, but there's some architecture that would have to go into. You can imagine all these various layers of interconnected neurons. You want to have weights for the information based on biases. You'll want to make sure you do some training. There's the generative process to the AI along the way. There are transformers involved as part of the architectural approach, which basically revolutionizes the natural language processing and the generative text models to give you a highly efficient text generation as an output. So I just wanted to touch on it, but there it is, and other topics there for further study. Now, I have to also touch on LLMs, or large language models. Large language models are a part of this architecture type of artificial intelligence that are specifically designed to understand you and to generate and interact with you in a way that mimics our own natural communication. And so these LLM models are based on this, I've been mentioning, just touching on deep learning architecture, particularly the transformers that I just touched on lightly, right? So it's not really that important, just trying to give you a sense of the layers involved here. And so LLMs are trained then using deep learning architecture, using transformers. They're trained on vast amounts of body, hence large. So the large in LLM refers to the scale of the model, right? It includes any number of parameters or variables that the model is going to learn from during its training. And data sets become very important, right? They're trained, LLMs are large language models, are trained on extensive data sets that include books and articles and websites, other text sources. Um, they're trained and then enabled to learn the complexities of language, grammar, context, even sarcasm and emotion, etc. Right? I mentioned previously transformer architecture. So most LLMs are based on this transformer architecture, right? Which is going to use attention mechanisms to process text in parallel rather than sequence. So it's not going in line, but it's all this data being processed in parallel. And this allows the model to consider the context of a word or phrase by looking at the surrounding text and making it more effective, right? And of course, then you always want to fine tune it. There is RAE, responsible AI. I just wanted to touch on that. This refers to the development and deployment of any AI system in a way that prioritizes ethical principles, fairness, transparency, accountability. What we want to do is minimize the potential for harm. So, the goal of responsible AI is really to ensure that AI technologies are designed and used in a way that's aligned with our social values and human rights and addressing sources around bias and discrimination and privacy laws and the broader impact on society. So consider that, I think, in your approach to AI. Fairness, non discrimination, transparency, accountability, privacy, security, inclusiveness, human centric design, even maybe safety and reliability, ethics, etc. Um, because there are a lot of good that can come from it, right? Done appropriately. There are organizations like the United Nations and various tech companies that are promoting the use of AI to address global challenges, climate change, poverty, health, etc. And these initiatives have to ensure that AI is used in a positive social way to create positive social impact. There's bias that can be part of it, right? IBM had a AI Fairness 360, and Google had the What If tool, and they're designed to help developers detect and mitigate biases in AI models, ensuring the systems are fair. Ethical guidelines, companies like Microsoft and Google and others, they have set ethical guidelines for AI development. There are also regulatory frameworks. The EU recently passed the AI Act. You can look that up. It's a good framework aimed at ensuring that AI systems are safe, transparent, and respect fundamental human rights. Right. In the United States, we also, NIST recently published AI guidelines. You can look those up as well. Now, why do we fear it? Well, there are risks. So I don't have to go to all these, but I just wanted to touch on the fact that we all sense AI technologies offer huge benefits. Yay. But they also come with risks and challenges. And that's part of this coursework and understanding technology that transforms. And I list here a bunch of risks along the way that you can do your own research on. That's its own class by itself, right? AI governance is also part of the solution, right? Some of those frameworks I mentioned, the EU's AI Act, the NIST, the US has National Institutes for Standards and Technology. They have also produced guidance as governance for AI. So you may want to look there as well to reduce biases and discrimination, etc. That's it. Let's go back to the lesson and off to the assignment. I hope this was fun. Some are going to love it. Some are going, ah, it's too much. And some are going to be like, oh, it hit the sweet spot. See you online.